midst of a pandemic, what do you think of when you hear the word virus?
Now, before you panic, you have to remember the old American idiom. There's always two sides to a coin.
Let me show you a good virus for us. Our friend Bacteriophage, or phage for short. Bacteriophage gets its name from bacteria and Greek phagein, which means to devour. Simply put, it means that bacteriophage only kills bacteria.
How does it exactly work? It is actually quite simple. A bacteriophage is just like any other virus, except it only infects bacteria. Now let me show the structure of a bacteriophage.
The circled parts are the most important components.
All viruses are like obligate parasites, since they cannot reproduce without a host. So phages must infect a specific species or strain of bacteria in order to reproduce.
When a phage finds a type of bacteria with compatible protein receptors, it lands and pins onto it with its tail fibers. Then the tail fibers contract and the tail pins penetrate the bacterium's cell wall. Lastly, the genetic information of the phage is inserted and incorporated into the bacterium's DNA. In the lytic cycle, the infected bacteria is hijacked to produce viral proteins and genetic info. More and more new viruses would assemble within the bacterium host, and the bacterium eventually bursts, or lyses, releasing more viruses to infect and kill more bacteria.
Although the bacteriophage therapy is US FDA approved in some food industries in order to prevent some food poisoning from bacteria, it is not approved as a medical treatment option. While there are still many aspects to be repeatedly tested and verified, there are some advantages and benefits we know for sure.
Due to our prominent use of antibiotics, the rise of superbugs, or drug-resistant bacteria, is becoming a very alarming medical issue. While finding new antibiotics are time-consuming and costly, phages can be easily found in nature. If superbugs evolve to become drug-resistant to antibiotics, then there can also be mutated bacteria that becomes immune to phages. However, it is energetically expensive to maintain both immunities. Therefore, immunity to one type of treatment increases the sensitivity to the other. By using both treatments for chronically infected patients, it increases their chance of recovery. Another advantage of phage therapy over antibiotics is its selectivity. Imagine that you have a garden. The ferns cause allergic reactions representing infectious bacteria. The flowers support your garden's ecosystem, representing good bacteria. If you use an herbicide, representing antibiotics, it'll kill the ferns and the flowers. However, if you hire a professional gardener to remove just the ferns, representing bacteriophage, removing targeted bacteria, then you and your flowers would have a happy ending.
Currently, there are some researchers that are developing a nasal vaccine spray for COVID-19. They use engineered bacteriophages that are structurally similar to the coronavirus.
Hopefully, the properties of bacteriophage can become a bastion of light in these uncertain times. Thanks for watching.